In this video, we're going to do some examples on some more motion calculations. And for today, I would like you to have your formula sheet in front of you. And even though the questions tell you which formula to use, it's a really good idea that if you've got your motion formula in front of you, one of the mental decisions that we need to make is what formula we use. And right now, we've got a few formulas to pick from. We've got our speed formula, or velocity formula, where the velocity has to do with the distance in reference to time. We also have our acceleration formula, where the acceleration is equal to something to do with the speed over time, change in speed over time. Over the change in time. Now, if I grab my formula in front of you, you've also got a Newton's second law, F equals ma. We're not up to that section just yet, but we will be soon. And we've also got a momentum formula, where we use P for momentum, where the momentum of an object has to do with how heavy it is and how fast it's going. There are some other formulas on here that we can use for today as well. Just be aware, this formula just here is just the acceleration formula rearranged. And this formula just here is actually derived from this formula and this formula combined. So I might jump into some examples, show you how to do the numerical calculations for the examples, and then if you'd like to stay back and I'll go through where these equations come from, for those who are interested, you can hang back and you can listen to that part of the video. So for your motion type problems, I want you to step through a process, and the process I'd like you to step through is that the first thing I want you to do is to find what you're looking for. What are you looking for? Once you know what you're trying to find, for example, in this question here it says what is the final speed, so clearly what you're trying to find is the final speed. You can have a look at your formula list or use common sense to think about how you would actually go about finding the final speed. So there should be a formula that you can use. So step 2 would be identify the formula. And once you've identified the right formula and you've written it out, you can then put the numbers in the question into the formula and find your answer. So sub numbers into formula. And then you press enter on your calculator, so you find the answer. And for this section, I want you to write a sentence about what your answer means. And because we're in science, it's really important that we understand what on earth does this number actually mean that we get in the end. We live in Australia where we want independent thought. We want people and individuals to be able to think for themselves. So there's no point if you go through this scientific process and get your answer and you have no idea what the answer means. So please, at the end of this step process, you need to write a sentence, explain what your answer means. Now, once you've done that, hopefully this will enable you to pick up on 90% of the little mistakes that we could accidentally make along the way, and so we could go back and rectify those mistakes and then get an answer that's relevant. So this last step is very, very important. Okay, so let's step through that 5-step process for this example just here, example 1. So my first thing that I want to do is I want to think about what is the question asking and what am I trying to find. And to do that, I'm going to draw a little box And inside that box, I'm going to place what I'm trying to find to remind myself about my end goal. We're in a boat and it's traveling 5 meters every single second. So after 1 second, it travels 5 meters, 2 seconds, 10 meters, 3 seconds, 15 meters, etc. and so on. When we open up the throttle, it speeds up, it accelerates, and the speedo changes or goes up by 1.5 every single second. The acceleration is 1.5 meters per second squared, and it keeps doing this for 20 seconds. What is the final speed? Somewhere in here there's a question. The question part is the last bit, so I've underlined it. What is the final speed? That's what we're trying to calculate. And to do that, to calculate final speed, we're going to use this equation over here, and we need to know that this v and this u, the v talks about something, the final speed, and the u talks about how fast we're going at the start of the situation. So this is the formula that I'm going to use. To use this formula to find the final speed, I need to know how fast was I going when I started, 5, and then how much my speed is increasing, at what rate, 1.5, and it keeps accelerating for 20 seconds. So because I'm finding the final speed, I'm trying to find v, and my units for v are meters per second. Step 2, what formula do we use to find v? This one. So I draw a little box and I put the formula in that box. Step 3, sub the values in the question into the formula. Now because I'm making substitutions, it's very important that we use brackets to help us when we encounter negative values so we don't get confused with whether there's multiplications or additions or subtraction going on. So I'm going to make a substitution for u, a, and t. U is the initial speed. How fast was the speed goat going at the beginning of the situation? It was going 5 meters per second. It's accelerating by 1.5, and we're doing that for 20 seconds. 1.5 times 20 is 30. So the final velocity is going to be 35. Now the last step, step 5, is to write a sentence to explain your answer to see whether it's relevant. So after accelerating for 20 seconds, the boat is now moving 35 meters every single second. And I'd like to put a box around that. Now, does this answer seem realistic? It really doesn't. 1, cars don't accelerate at a constant rate. The faster you go, the harder it is to accelerate. And 2, if I wanted to convert this into kilometers per hour, we said last lesson you times it by, you times this by 3.6. If I do that on a calculator right now, you'll find that you're traveling very, very quickly. 126 kilometers an hour. It's a pretty quick boat. So it's not a very realistic question. All right, I'm going to do the next example for you. It's going to use this equation. And in this example just here, I'm going to go into more depth. And to help us with the question, I'm going to add another step in there, an initial step, which is to draw a picture. Next example. For the boat that we just talked about before, how far did it travel throughout this situation? So I'm going to draw a picture. And for your motion pictures, I want you to always start by drawing 2 dots. And I want you to imagine this first dot talks about imagining you take a picture when the situation commences. So this is the start. And then we take another picture on our camera when the situation finishes. At this moment in time, there will be a certain speed. At this moment in time, there will be a certain speed. The object will have moved some form of distance to get from here to here. And remember, we use S for displacement. In order to get from here to here, there's probably been an acceleration. And to get from here to here, some amount of time has passed between the first photo and the second photo. And from here, we could write down all the things that we know and then think about what we're trying to find. Because this relates to the previous question, I can sub in some values. So I'm going to start by thinking about how fast was the boat going initially, U, and how fast was the boat going at the end of the situation. We started at a speed of 5, we finished at a speed of 35. So we started with a speed of 5 and we finished with a speed of 35. How long was it in between the photos? How fast were we accelerating? And how far did we travel? It says it took us 20 seconds, and it says our speed was increasing by 1.5 every single second. So the only thing out of all of these things that I don't know is S, which is how far the boat actually travelled. This is a nice little strategy to get you started to understand how to attempt the problem. So if you're not sure how to do the problem, this is how you should start it. Draw up your little diagram, 2 dots, what's happening over here, what's happening over here, how long did it take, what was the acceleration, and how far have we travelled. And every different problem will have different variables that we need to sub in. So if we go back up to our little steps, the first thing I'm going to want to write down is what are we looking for, and then what formula we're going to use. So within this question, there is an actual question posed, and I'm going to underline it. What distance did the boat cover? So distance, displacement. So in my little box at the bottom, I'm looking for displacement. S is displacement, it is not speed. Very strange why they have S for displacement, not speed. How do we measure speed? Speed means how fast are you moving every second. I just fell into that trap. S is displacement. It's a distance. Distance is measured in meters. To find this, I need to use a formula. So I need a formula that involves all of this. So it actually tells you the formula that we're going to use. And here it is. We haven't used this one before. It's not on your formula sheet either, so you would not expect to get this question in an exam or in your test, a half AT squared. Okay, we're going to make our substitutions. Whenever I make a substitution, I'm replacing the variable, the letter, with a number. So I'm going to use a set of brackets and sub that in. Going to replace t with something. Going to replace a with something. And I'm going to replace t squared with something. So don't forget that squared term. Let's do a different colour. U was, have a go at pausing the video just here, everyone. Pause the video, see if you can sub in the right numbers, see if you can find the answer yourselves. Okay, thank you for those people that paused the video. Let's go ahead and solve this. You should have had U was 5. And we do that for 20 seconds. And the acceleration was 1.5 and the time was 20 seconds. Take out your calculator. 5 lots of 20 is 100. 20 squared is 400. 400 times 1.5 is 600. Half of 600 is 300. So 100 plus 300 is 400. Now that I've found my answer, remember I would like you to write a sentence that explains what your answer means. Okay. Our answer is 400, and it has to do with displacement, distance. And we're talking about the speedboat. We're talking about the speedboat accelerating at 1.5 meters a second for 20 seconds. So over the 20 seconds, the boat has traveled 400 meters. Okay, perfect. Please follow that 4 or 5 step process. With your questions on the following page, just be aware, sometimes once you find your formula, you may have to rearrange it to get your answer. And I know in Year 10 Maths, the last topic that you looked at in Year 10 was rearranging equations. So you've all had practice rearranging equations. If you're not sure how to rearrange equations, I would just take out your computer, go into Google and ask Google how to rearrange it for you to make sure that you've rearranged it properly. But it is a mathematical skill that you need to practice if you want to be able to solve these problems. So make sure you're up to date with rearranging your formulas. Okay, so you can stop, you can have a go at the work now. If you'd like to stay on the line and watch me rearrange the formulas in the subsequent exercises, I will do that for the next couple of minutes, and you can pause and rewatch to see how I've rearranged those formulas. Other than that, you can head off and do your questions on the following page for me. Okay. So just bear with me. I'm just going to find the following questions. I'm going to read the questions and look at what we're trying to find. So I'm looking at the questions to see ones that need rearranging. Questions 1 to 4 don't need rearranging. Question 6 doesn't need rearranging. Question 7 does not need rearranging. And question 8 does not need rearranging. So I spoke too soon. We don't need to rearrange any formulas, but I might show you how to rearrange one anyway. So the formula I'll show you how to rearrange is the acceleration formula. Acceleration is your change in speed in reference to your change in time. Now, in order for you to have a change in speed, you need to have a starting speed and you need to have a final speed. For example, you finish at a speed of 10, you start at a speed of 2, so your change in speed, of course, would be 8, because you've gone, started at 2, you're now at 10, you've gone up by 8. So I'm using U and V to represent how fast we are when we start and how fast we are when we finish. How did I get 8? I went 10 take away 2, or V take away U. So this is another way to write the acceleration formula on your formula page. It just says change in speed. So this would be another update for you to do. What would happen if you got a question where you had to find t? Clearly t is not out the front, so you need to rearrange for t. So if you want to rearrange something, my advice is to write out the formula twice. First line is so that you can see what you're looking at, and the second line is for your workings. Now if I want to find t, the first thing I'm going to do is I'm going to draw in a fraction line over here, so I have a top and the bottom, just like over here, and I'm going to put in a set of brackets here because there's a subtraction or addition, and I'm going to try and move this t to the other somewhere else. And to do that, I'm going to put a 1 on here, because if I put a 1 underneath, it's a divided by 1, which is just a. I haven't changed anything. If I wanted to find t, the first thing I'm going to do is flip this fraction upside down. What I do to this side of the equation, I must do to this side of the equation. So I'm going to write the result underneath. So when I flip this, I now have 1 divided by a. And then I have RT, and over V take U. And because t is on the right hand side of the equation, and I'm trying to find t, I'm going to reverse the equation. So I'm just going to write all of this on the left. So I haven't done anything, I've just put that over there and that on that side, so that way t is on that side. Now the last thing, step I need to do is I need to get rid of this v take u. And notice I've grouped it together because it is one object, because it's all underneath the fraction. So I'm going to rewrite the equation twice. And to move this to the other side, I need to multiply by v minus u on the top. When I multiply by v minus 2 on the top, I've got v minus 2 on the top, v minus u on the top, v minus 2 on the bottom, so it cancels out. But because I multiplied by v minus u on the left, I must multiply by v minus u on the right. And just write what's left over. That should be my answer. T divided by 1, so nothing, so I'll just leave it at t. 1 times v minus u. One lot of something is just one lot of it, so I don't even really need to write the 1 out either. And I now have a formula that will find t if I know the change in speed and I know what the acceleration is. I'll do one more to same formula, except how to find v. So if I want to find v, write out the formula twice. Drawing my fraction line, this time I want to get v all by itself, so I need to move t to the other side of the equation. T is going to go from the bottom to the top. The reason why it does that is to cancel out t on this side of the equation, I need to put a t up the top. So I've got a t on the top, t on the bottom. They cancel, but because I multiplied by t up here, I also need to multiply by t on that side as well. So the result would be a times t is equal to the final velocity minus the initial velocity. Then I'm going to reverse, so what I've got on this side, I'll just write on that side. And the last step is I need to move this minus u to the other side. So to undo a negative u, I add u. And when I do that, these guys cancel, and I'm left with u plus at. Now the reason why there's a plus in between is because this a term is positive. There's no negative, so there must be a plus, not multiplying. This is the formula that they gave you on that page. This is just the acceleration formula rearranged. This is just a number sequence. If I have a number sequence where the first number is 10, and to find the next number, all I do is add 2. If I look 3 seconds into the future, if my starting number is 10, and then I look 3 seconds into the future, and every single time into the future I'm jumping by 2, in total the speed's gone up by 6. So this bit here talks about your speed increase. So you start with a speed of 10, clearly 1 second later you're travelling at 12, another second later you're travelling at 14, and during the third second you're now travelling at 16. So all this here is it's generating a number sequence where this first term is the first number in the sequence, your starting speed, and this second part of the equation, the a and the t, talks about how much your speed either goes up by or down by. So if there's a minus sign there, the sequence is getting smaller, your velocity is getting slower. If it's a plus term, your velocity is getting larger. If you follow that logic, if the starting velocity is 10, and if we looked 7 seconds into the future, every single second we're adding 2, so in total the total increase would be 7 lots of 2 is 14. So you're starting at 10, your speed increases by 14, so the final speed would be 24. Okay, we'll tune into next lesson. That's it for the motion side of things, kinematics. Next lesson we're going to be starting on Newton's laws of motion. So on style we'll be looking at a new topic, but all the topics on style are still available for you to look at and browse at your will.